Welcome to Protocols. In this chapter, we'll be looking at the OSI model, TCP/IP, ICMP, UDP, ARP, DNS, SSH, SNMP, and SMTP. The top layer is the application layer of the OSI model. It's a 7-layer model. This layer is the closest to the user. When you think of this layer, those protocols of this layer allow the applications to communicate to applications on remote systems. You can also think of it as interacting with applications that we run on the PCs. Don't think of them as the actual applications like Microsoft Word or Excel, but think of them as interacting with those applications. Some protocols at this layer: SMTP, HTTP, LPD, think Linux, Telnet, and TFTP. Next layer down, layer 6, is a presentation layer. No protocols work at this layer, only services. At this layer, we're thinking of conversion. We're thinking of standardized formats, conversions between different graphics formats, possibly different sound formats, just different systems of conversion. GIF, ASCII, Unicode, JPEG, TIFF. Other functions that take place at this layer, you think of encryption, also decryption, compression, and the opposite, decompression. Session layer. At the session layer, we could imagine a phone call occurring, and you make the phone call, you actually dial, you say hello, you do your communication, you have dialogue, and then you say goodbye and hang up. Essentially, dialogue management between the programs. Access control, recovery, and synchronization. As the phone call analogy, we look at the setup of the call, the maintenance, the teardown of the session. We've basically had a communication session when we've made a phone call. At this layer, we can also think of how the conversation occurred, whether we were allowed to have full duplex or half duplex. With full duplex, think of being a telephone again, being able to talk at the same time, not that you hear each other, but being able to talk on both ends of a phone call. We have two-way conversation at the same time, versus half duplex, only one application can communicate at a time. Somewhat reminds me of like CB radio. You speak and you say over, and then the other person speaks, and then they say over, one at a time. Protocols that you could associate with the session layer: SQL, NFS, and RPC. Transport layer. I imagine reliability when I think of the transport layer. Two popular protocols, especially at the very bottom of the slide, is TCP and UDP. But I mostly think of TCP. A lot of what we do is TCP based. When you think of the transport layer, it's end-to-end packet transfer using connection-oriented or even connectionless protocols. It's not always perfectly reliable because we do have a protocol called UDP, and UDP is actually going to be connectionless. Transport protocols are concerned with getting data from one system to another. It's not all the way at the application to application, like application layer. It's not communications up to quite that high. Many application layer protocols that we use will tie into a transport layer protocol such as TCP or UDP. And that's a pretty good picture on the slide. As you can see, they've got Office and Outlook and Internet Explorer at the top, but yet all of those tie into the transport layer, assembly data into a stream. Also at this layer, we are segmenting the appropriate size of packets for the processing by the network layer, because what we're transmitting may not be the right size, so that has to be segmented. The protocols, again, that you would know more of would be UDP and TCP, because these both are within the TCP/IP protocol suite. SPX was an old Novell protocol that would be kind of comparable to TCP. When I think of the network layer, my mind, just like the slide says, routing. I think of routers. I think of just basic routing of packets. Think of IP addressing in modern day. So addressing takes place at this layer. We look at routing protocols at this layer. Anybody who studies a class on Cisco routers would be spending much time at the network layer in their discussion. When a packet is sent down from the transport layer, the network layer protocol adds the address and creates a network header. As we go through the OSI model, information is passed down from the top at the application layer, and as it goes down through the layers, there's always additional information being added. Think of it as addressing information, telling the packet where to go. We also associate data at the network layer as being called a packet. We can add security to this information through a protocol called IPsec, IP security. So confidentiality, authentication, and integrity is basically added to what you have at the network layer through the IPsec. Very commonly used with virtual private networks, VPNs. So you'll hear people talk about, actually you'll hear it later, but L2TP, Layer 2 Tunneling Protocol with IPsec. Some protocols that work at this layer: IP, RIP, ICMP, IGMP, IGRP, and BGP. Then when you move down to the data link layer, Layer 2, at this layer, we, equipment-wise, not so much discussed here, but equipment-wise, I think of a switch, like a Cisco switch, for example. And they say the sender breaks down data into frames and transmits sequentially. Technologies you could think of here would be, we used to have token ring. Ethernet's quite common now, and as well as ATM. And when we think of the data at this level, a lot of times we'll use words like frame or framing. These days, we use media access at this layer, and it's carrier sense multiple access with collision detection, but CSMA. There's also polling. You can imagine that might be a mainframe environment. We could also look at an older technology of media access at this layer called token passing, if you can imagine token ring. Has synchronization and error control. When you break the data link layer down into sublayers, we have the 802.2 and the 802.3. As you can see in the picture, the 802.2 is the closest to the network layer, which is the logical link control. And at this layer, information can be passed up to, when we're going the other direction, up to the network layer, interacting with LLC, logical link control. And at that layer, it would identify whether we were talking IP or, in the old days, IPX for Novell. And the 802.3, we start thinking more of a technology, the media access control layer, MAC layer. Could associate that with Ethernet. There's other ones like 802.11, think wireless. 802.5 was the token ring. Again, token ring has lost popularity due to Ethernet being superior to it. We've got everything faster. But the data link layer, again, think switches. Switches are quite consumed with what is your MAC address. They learn the MAC address. That's a physical address of your network card. And that is at this data link layer. And that was the big, great thing about switches when they came out over the existing hub devices that we had, is there was finally a MAC address awareness in the device. So when you wanted to communicate with another device, you would actually just look at a table that the switch would have, and it would have the MAC addresses in there once they were learned. That would spell out what PC was connected to what port on the actual physical switch. This occurs, again, at the data link layer. Physical layer. When it really comes down to these bottom layers especially, physical layer, for example, layer 1, if everything's not correct at the physical layer, it's not going to work at a higher layer. And when you think of the physical layer, you could simply think of even cabling and the connectors. And if you've got the wrong type of network cable, the wrong types of connectors, or the cabling is bad, you're not going to get anywhere. So you're thinking bits, 0 and 1. And with bits, bits are turned into voltage. So encoding a voltage binary representation varies between your different technologies. You've got your local area network, your metropolitan area network, and your wide area network technologies, and there's some definite differences there. And this does provide standards for the different interfaces to the different media that we have. And there's going to be some differences as well with the electrical signaling and the format. And there's also wireless. We use radio frequencies for wireless. We're not using what some books may call bound media, basically cable. With wireless, it's like in the airwaves. It's just out there in the air. We can't really see it. But again, the physical layer, if everything is not correct, you've got the wrong type of cabling plugged into your existing cabling, nothing's going to work well above that, if at all. So there's definitely a dependency from the layer 1, which is a physical layer, all the way up to layer 7, the application layer. Now, thinking of the protocols, here's your layers. Again, physical, all the way up to application. Layer 1's at the bottom. Layer 7 is at the top. It's kind of nice to see some of the more interesting protocols here. If we were to start at the bottom, I'll just pick out some of the more interesting ones. Physical layer, you're thinking of connectors. And a lot of what you're seeing here is really wide area network connectivity that they're showing here, like the EIA TIA 232. And you think of that as, some of us will go around saying RS-232 or serial. So these are some of the varieties of serial connections, but there's many more beyond that. And then at the data link layer, we used to have SLIP, but that was replaced by point-to-point protocol. And at the data link layer, again, there's a MAC address awareness. There's an understanding of what is your MAC address. Many protocols will depend on PPP, point-to-point protocol. Even back in the dial-up days, we were using PPP, and we still do. I'm not going to go through every single one of these, but of interest, there's ARP, Address Resolution Protocol. That's a really nice one to be able to translate your MAC address. Looking at trying to understand what machine, what MAC address, and of course that table. I'm going to try to show you that. Okay. Like this is an ARP table. You can actually see what IP, which is layer 3, what IP address goes with what physical address. Okay, and the ARP table can be corrupted, due to hacking and hackers, but normally we trust it. Your computer relies on it. Reverse ARP would actually just be the opposite direction, but normally you're thinking, I know my IP, I need the MAC address, and that's what's usually happening with ARP. If I want to interact with this 192.168.1.4 device, then my computer will check its ARP table and say, oh, that's the physical machine I need to go to. And that's kind of the nature of ARP. I know the IP, I need the MAC. Reverse ARP just goes, I know the MAC, I need the IP. L2TP, I mentioned that one. That's another interesting one. L2TP, Layer 2 Tolling Protocol. I think of that as being used with virtual private networks and incorporated with IPsec to give you security at the network layer. The network layer is layer 3. With that, some primary protocols these days would use IP. And when you ping a device, the messages that you get back to let you know, echo reply, that the device is there, you are relying on a protocol called ICMP, Internet Control Message Protocol. Many times, though, ICMP is being blocked at the router. They're actually router / more so firewall. Routers can have firewalls in them, and that's because people who kind of gotten tired of denial of service attacks, so they try to block the ICMP, which would help the hacker, of course, know that you're there and see the connectivity, and so it's blocked many times. RIP is a routing protocol, very basic one. IPX, just realize that's a much older protocol you most likely won't run into for Novell. Transport layer. When you think of the transport, since we live in a TCP/IP world, I would say just TCP/UDP would be of great interest. TCP gives you the reliability. Certain protocols at the application layer that need the reliability, need the confirmation back and forth, that we have a reliable connection, like I send you some information and you come back and say, yes, I got it, that's TCP. If I just send you information and it's a best effort delivery, maybe like sending a postcard, I hope you got it, that would be UDP based. Some things we do application layer wise, maybe like video streaming, we would want to just send the information and we don't need a confirmation back so much. It would be a cyclic redundancy check, but that would be it. But it'd be much quicker to not have to confirm and always say, here it is, did you get it? Yes. Here it is, did you get it? Yes. That's TCP. UDP is like, here it is, I hope you got it. We'll do a little check to make sure everything went well, but it won't be perfectly reliable. Secure Sockets Layer, SSL. You see that used for secure websites, and you'll see it represented as HTTPS, by the way. SPX, again, that's Novell. I'm not putting down Novell, but Novell of today is not using that anyway. That was, gosh, mid-90s and a little bit later, so pretty old. Session layer, remember that was like having a communication session compared to a phone call. Popular protocols, Microsoft has always had NetBIOS built into it. There's NFS more on the Linux side. SQL, remote procedure calls, RPC. Presentation, remember that one was conversion between different formats. It was compression, decompression, a lot of different format differences between, again, different graphic formats, different sound formats, ASCII, EBCDIC. Application layer, that's layer 7. When you think of this layer, very popular protocols. I'll just do the best ones. DNS, domain name system. When we go out to the World Wide Web, we type in www.microsoft.com. We expect that to be resolved, and that's due to DNS. FTP, File Transfer Protocol, extremely popular for transferring information. If you haven't heard of TFTP, it's like a lightweight FTP. Let's see, SNMP is a big one, Simple Network Management Protocol. And with that one, we think of network management, managing devices. Another interesting one, basically Simple Mail Transfer Protocol. Think of email. Telnet, people who use Cisco routers and need to remote into the Cisco routers would use Telnet. And HTTP, like any website you go to that's not secured, and that's application. So the OSI model is a 7-layer model. If you were to say what is layer 8, a lot of people would tell you the user, because that's where we interact. And with these layers is a layer 8, which is not an official layer.